Hey guys, myself Ankita. In this video, we shall see another problem on LeetCode. Given a string and integer k, return the maximum number of vowels in a substring of s with length k. So vowel letters are A, E, I, O, U. Maximum number of vowels in a substring of given length. So the given question is, let's say the string is A, B, C, D, E, and they're given the substring length equal to 3. K is equal to 3. So the substrings possible are A, B, C, then B, C, D, then C, D, E. That's it. So A, B, C, B, C, D, and CDE. So of length 3. So if you see in the first substring, the number of vowels are present is A only, so 1. In BCD as well, it's 0. Then coming to CDE, it is 1 because E is a vowel. So maximum number of vowel letters found in any substring is 1 here. So you have to return this as the answer. If you look into the given example, substring length is 3. So start with ABC. 1 is the vowel number of vowels present. Then go to BCI, 1 again because I is the only one vowel present. Then CII, this time 2 is the number of vowel that is present in the substring because II. And if we take III, that is 3. So, so far now we have seen 3 is the maximum number of vowel letters present. And 3 can only be the maximum, it cannot be 4 because the substring length itself is 3, right? So, maximum number of vowel letters can be 3 at most. So, next if we take IID, it is 2. Then IDE, it is 2. Then DEF, it is 1. So, maximum is 3 and we return that. Similarly, it works for all the other examples. So, what's the approach to solve this problem? The approach to solve this problem is usually what we can do is when I try it, like I ran for two for loops. So the for loop 1 will be length I equal to 0 till I lesser than the length, string length, lesser than or equal to string length minus k. Because if 3 is the length, the last number it should be till here, d. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 3, 6. So 0, 1, 2, 3, 4, 5, 6. Till the sixth index only you can iterate. Why? Because in the next for loop, I'll be running a j equal to I and j lesser than I plus k. So if starting is 0, 0 plus k is 3, so 0, 1, 2. Then again I will be 1, so 1, 2, 3. Then again I if I equal to 2, 3, 4. So I keep count, I find count at each time, count plus plus. We increment the count only if the vowel is present. So that if condition you have to give if vowel is present or not, I increment the count if vowel is present at that particular character. So at every jth loop, you have to reinitialize count equal to 0 and we will have one more called maximum count. So after this for loop, find the maximum count present. How do you find that? We have the max minimum max function. So math.max of count and max count. Count and max count. So this was the approach which I saw and class you return the max count. But I found it couldn't handle the larger strings because it was when time it exceeded problem since the complexity is more. So the other optimized solution was uh, to solve this problem using sliding window approach. So let's take the example lead code now. Okay. So how do you use using sliding window approach? Sliding window means what? So if k is equal to 3, the substring will be 3. Then you slide that next 3 and again next 3. Similarly till the end of the string. So how do we perform a sliding window operation? So as I said before, initially the slide will be first 3 letters because k is equal to 3 in this case. K is equal to 3. So initially the substring length will be 3 and sliding window initially will be first 3 letters. So we run the follow I equal to 0 till I equal to I lesser than s dot length minus s dot length and I plus plus. You have to check if and we will define a vowel function. So is vowel and that parameter will be is vowel of written type boolean we will say. character will be C. So if s dot character at of I, character at of C is equal to A or I or AI, O, O, AEI, OU. If any character is matching, then you return the particular character. So here what is if condition is not required is boolean. So private it will be boolean is vowel of character C. Return C equal to A or C equal to E, A, E, I, O, U. All these things. So once you return this, now you have to check whether if is vowel of S dot characteristic of I. So here you give the whatever return you have found. So yes, a character at C is equal to either of these characters. Then you increment the count plus plus. Fine. So this you can be done until k equal to 3, count plus plus. So but what if you encounter the last thing, like the last character at the substring? In that case, if I is equal to k minus 1 position, it is 2. Then you have to check the maximum count. So here you give the function max count equal to math.max of count comma max count. Fine. So, as I said, the logic here is nothing. So, once we have defined the vowel function, that you return the particular character. And you check, you call this vowel function in the for loop. So, if it is a vowel, then you increment the count. And this count, we are incrementing only till the substring, whatever k is present. So, 1, 2, 3. Till here, you increment the count. So, for E, the count will be incremented. So, count will be 2 now. So once you reach the end of a substring, that is length k equal to length, three lengths are formed. That means I will be nothing but k minus 1 because indexing starts from 0. So if I equal to k minus 1 in this case, then we find the maximum max count equal to math.max of count comma max count. So this is okay. What if you encounter the next character now? I equal to k1, 2, 3. If I is equal to 3, then what we have to do? So if I is greater than or equal to 3, but again, one more condition you have to handle. If in any case I is greater than or equal to k, 3 means here k. If I is greater than or equal to 3, k, and in that case, we are sliding the window. So the sliding window means the next substring will be this, and you have to neglect this character. So how do we do that? So if I is greater than or equal to k, you have to check this I minus k value. I is pointing here, so I is 3. 3 minus 1 is 0. So I equal to 0. So if is vowel of I minus k. So I minus k position is containing a vowel. Then what you have to do? You have to decrement the count this time because we are sliding the window. So the substring is here. We are excluding this. So if in case this is the vowel, then we have to decrement that count because for this substring, this letter is not gonna intake. So that is one thing, baby. Then again you check in this position itself. T is set. If that is vowel or not. If that is vowel, then increment the count. So when you slide the window, you just you are sliding the window by one position. So you have to check the character at that position whether it's vowel or not. And also you have to check the character at the position which you are sliding, the previous to this sliding window. So if this is vowel, decrement the count. If this is vowel, then increment the count. That is one thing. And each time, once you have I greater than or equal to k minus 1. So from this position, each time you have to look for the maximum count because this from here only you get the three length substring, right? So one, so that's why you found the maximum count. So again, I'll tell properly because I'm not satisfied with the explanation. So what are we doing is at first we have the substring three length, right? Till here you find the count is vowel function. it is a vowel, you increment the count, count plus plus. So once you reach k equal to I equal to k minus 1 position, that is the end of one substring. From all here, you have to count the maximum count. Check for the maximum count, that math.max. Also, when you reach here, the next sliding window will be EET. So in this case, you are including the next character but excluding the previous first character in the previous sliding window. So you have to check whether the character here, particular character here is vowel or not. And also the character is the previous sliding window, first character of the previous sliding window is vowel or not. If this is a vowel, then you decrement the count. If this is a vowel, you increment the count because this is the sliding window. So we have to exclude this. If in case this is a vowel, the previous count was having this vowel, right, sliding window. Now you have to decrement that count. And if this is a vowel now by now, then you have to increment the count. That is one thing. So this will do until the last step in the array. So now you have this next etc. So while doing etc, you check whether this e is vowel or not. If this is a vowel, then you decrement the count. But when it comes to see if this is a vowel, then you have to increment the count because for this sliding window, right? Previous sliding window was EET. So in that EET, that count was including this E also. Now, when you come to this sliding window, you have to exclude this count. That's why you check whether the I minus kth value is having vowel or not. If it is having vowel, then you're decrementing count. And the particular character which includes the sliding window, you increment the count. So this will do until the end of the array. So this is one optimal solution to the problem. And I'll code this and I'll explain again properly. So at first, at first we'll have one is vowel function. The private boolean is vowel of character C because we are inputting character here. So return C equal to A or C equal to E or C equal to I or C equal to O and at last or C equal to U. And this has to be outside this, yeah, because this function is entire one thing and the next function is start from here. Yeah, now it's proper. So now we can use this is vowel function directly instead of many times you are checking for C equal to I and if condition you have to check for whether the character is this. You just write a function, we'll call this function inside this function. So now you define two variables. One is count equal to 0, then int max count also equal to 0. So once you have to now run the for int I equal to 0, I lesser than s dot length and I plus plus. So at first what did I tell? You have to check for if is vowel of s dot character at of I, then you increment the count. That is okay. Then if I is greater or equal to k minus 1, then you have to check for max count equal to math dot max of count comma max count. Fine. Then one more condition we checked previously is yeah, I'll write once again. So if any where you find the vowel, then you increment the count. So if I is pointing here, I is pointing, you increment the count. So now just imagine the sliding window is this. So I is pointing here. Then you have to exclude this. So that's why this will be happen only when the I is greater than or equal to K. K is 3. This is a 3 position. So now check if I is greater than or equal to K, and is vowel of s dot character 80 of I minus k. Then you have to decrement the count. So apparently we will check for the maximum count only after this position because from here the subtraction will happen. And before do this, we have to check whether the count is vowel is present here or not. So if this is present, then increment the count. After that, you check from this position like every other character. The sliding when will happen, we find the max count. Then this is something nothing but so once you slide the window, like if you have etc and I is pointing here, now you are excluding this e, right? So we have to check whether this I minus k, I is nothing but 0, 1, 2, 3, 4. So I is 4, k is 3. So 4 minus 3 nothing but 1. So 0, 1. This is one position. So a stop characteristic of I minus k, if that is formal, then you have to decrement the count. Count minus minus. Why count minus minus? Because the previous sliding window will be having EET, which has the count for this E as well. So when you do the sliding window for the next characters, you have to exclude the count, vowel count of this. So that's why we are decrementing the count if the vowel is presented I minus k value. So if you go here in the sliding window, then this is not a vowel here. At that time, you need not to decrement the count because for previous sliding window of COD, you might have not included the vowel count for this C. That's why you're not excluding the C count value for ODE also. So that's the logic behind the problem. So after all this, just return the max count. Yeah. It's been successfully submitted. So if you have any notes, please drop it in the comment section. We'll come up with another video in the next section. And please subscribe to the channel and keep learning. Thank you.